What's up, guys? So last time we worked on some factoring sums and difference of cubes. So today we're going to be working on some solving inequalities with a degree greater than 1. Right? And for this, all we have to do are we just got to follow these steps. So let's go ahead and practice, right? And we'll break down the steps as we're going along, right? So here we're given the inequality x squared plus 6x minus 12 is less than 5x. Right, so first thing, step number 1, move all terms to one side of the inequality sign so you have a 0 on one side, which just means we have to subtract this 5x over. Right, and when we subtract the 5x over, this becomes x squared plus x minus 12 is less than 0. Right, step number 2, factor the expression if it isn't already factored. So when we factor this, we know the leading terms in both of the factors are going to be x because we have this x squared in front. Then I got to think, okay, what can I multiply to get negative 12 that's going to add up to 1, right? Well, that's just going to be negative 3, positive 4, right? Because negative 3x plus 4x will give me 1x right in the middle there, right? So that's going to be less than 0. Cool. All right, so step number 3. Set each factor equal to 0 and solve it. So I'm going to have x minus 3 is equal to 0. I'm going to have x plus 4 equal to 0. And then I solve, right? Solving for x here just gives me x equals 3. And then I get here x equals negative 4. Right? Step number 4, put these numbers on a number line. Okay, so I'm going to have my number line here. And you don't have to draw a super detailed number line. I'm just going to have one where we have 3, we have negative 4. And that's all we need on there. Number 5, test numbers within each interval, including the intervals out to negative infinity and infinity, in the original inequality statement. If the value makes a true statement, mark that interval on that number line as true and shade it in. Okay, so what that means is we're going to take a number from each of these 3 intervals and we're going to test it with our original inequality. If it makes a true statement, we know that'll be part of our domain. All right, so let's test. We'll start on the left here. Let's say we test with negative 6. Okay, so we're going to say x equals negative 6. We can write that in our inequality. We get negative 6 squared plus 6 times negative 6 minus 12 is less than 5 times negative 6. Right, and when we simplify that all out, we actually end up just getting that negative 12 is less than negative 30, which we know is not true. Okay, so we'll say this is false. Okay, so let's say we pick a number in between them. We could say, well, 0 is between negative 3 and 4. So we'll have, and 0 is really easy to work with, right? So we definitely like 0, because that would just be 0 squared plus 6 times 0 minus 12 is less than 5 times 0, which really just simplifies to negative 12 is less than 0, which is definitely true. So we like the middle part, right? That is a true statement. Then we just have to test the upper limit, right? This when we have a number that's greater than 3. So we'll say when x is equal to 5. So we would have 5 squared plus 6 times 5 minus 12 is less than 5 times 5. Which actually just ends up getting us 43 is less than 25. which we know is not true. I'm sorry, I know you can't really see that there. Right, that is not true. So this is false as well. So the only portion we care about then is this middle portion. So we would say the domain then, expressing the solution in interval notation, would be from -4 to 3, and we would put parentheses around that, right? Because we have this less than sign. It's not less than or equal to, so we want parentheses. All right, let's look at some more examples of that. Like number 5 here. So number 5, it gives us this inequality, 3x squared minus 31x plus 70 is greater than or equal to 0, which is awesome because it already goes through our first step where we have all of the terms on one side and 0 on the other. So the next step then is to factor this. Okay, so if I'm factoring this, I know because I have 3x squared, I'm going to have a 3x in one, right? And an x in the other, because it's the only way I can get 3x squared. And then for this, I like to just kind of guess and check. I'm going to want to put in terms here that are going to multiply to 70, and then when I kind of FOIL it together, it's going to give me that -31 in the middle. Well, if I put a -10 here, right, and a -7 here, this works well because I know I'm going to have to do 3x times -7, which gives me -21, right? And then I have -10 times x. Well, that's just -10x. -21x plus -10x gives me that -31x there. Right? And that's all greater than or equal to 0. Next, I have to set these factors equal to 0 and solve. So I have 3x minus 10 equals 0, and I have x minus 7 equal to 0. Well, this first one on the right here, nice and easy, we just get x equals 7. This one, I'm going to have to subtract 10 over, and I get 3x equals 10. Then I'm going to have to divide by 3. So I get x equals 10 over 3, which I can rewrite as x equals 3 and 1/3. All right, then I have to draw these numbers on a number line. So I have 3 and 1/3, and I have 7. Remember, they don't have to be fancy or you don't have to mark out a bunch of tick marks on the number line. We just have to put those two values down. Right, then we have to test on each of these intervals. So anything that's smaller than 3 and 1/3, anything in between 3 and 1/3 and 7, and anything greater than 7. Okay, so starting from the left here, we want a number that's less than 3 and 1/3. Well, what about when x is equal to 0? If x is equal to 0, right, we would have 3 times 0 squared minus 31 times 0 plus 70 is greater than or equal to 0, which just simplifies, right, to 70 is greater than or equal to 0, which works out great because that's a true statement. Right, then we can say, well, what about in the middle? Well, in between 3 and 1/3 and 7, I know 5 is in between there. Right, so I would just plug in my values again, right? So 3 times 5 squared minus 31 times 5 plus 70 is greater than or equal to 0. And that just simplifies down to -10 is greater than or equal to 0, which is not true. So we know this is a false statement. And then we can test as a number that's greater than 7, which let's just pick an easy one, right? 10. So we plug in 10, we have 3 times 10 squared, minus 31 times 10 plus 70 is greater than or equal to 0. This simplifies out to 60 is greater than or equal to 0, which is a true statement, right? So we care about anything that's greater than 7, and we care about anything that's less than 3 1/3. And these keep going on towards infinity and negative infinity, right? So we would write the domain then as negative infinity, right? Because this keeps going left towards negative infinity, and it stops at 3 1/3. All right, now notice this is greater than or equal to, so we would have to put a bracket around 3 1/3 because it's including 3 1/3. It would also go from 7 to infinity. Right? And we always put parentheses around the infinities. Right? But again, a bracket around 7 because it's greater than or equal to. Right? And this U just is like union, right? It's including. The domain includes both of those. So let's keep going. Number 6 here. Solve each inequality, express your solution in interval notation. Right? So here we have this inequality, and it's already given in a factored form, which is awesome because that kind of knocks out our first two steps, right? Set it equal to 0, and then factor it. So all we have to do are set these factors equal to 0. And x minus 3 equals 0. And solve, right? So we get x equals -2, x equals -5, and x equals 3. Then we just have to plot these on a number line. Draw a nice big one for this. We have -5 is the farthest on the left, -2 in the middle, and 3 on the right. And again, these don't have to be perfectly spaced or anything. But then we have to test, and this time we're going to test in 4 different spots. Right? So we just got to pick some numbers. Right? And we're not going to go through all the math here. Let's just say we tested at x equals -7. Right? And that ended up giving us -100 is less than 0, which is true. We can test when x is equal to -4, because that's in between -5 and -2. And that'll simplify to 14 is less than 0, which is false. Then we can test when x is equal to, we'll say 0, because that's in between -2 and 3. And when that simplifies down, we get -30 is less than 0, which is true. And then we can also test when x is equal to 5, because that's above 3, right? And we end up getting 140 is less than 0, which is false. So we only care about the parts that are true, which are just these two intervals here. So we would write that, because it's going from -infinity to -5. And remember, this is just less than, not less than or equal to. So we want parentheses around these numbers. And that's including from -2 to 3. Good, one last one. All right, here we have number 7. Right, and again, it's already factored for us. It's already set to 0, which is awesome. Now, just because it's this square here, doesn't really change how we go about solving this problem, right? This factor is still x minus 3, and this is still x plus 4. And we just want to set that equal to 0. So this is just going to be x minus 3 equals 0, and x plus 4 equals 0. So we get x equals 3. We get x equals -4. We're going to plot that on our number line. We have -4, and we have 3. And we're just going to test on these intervals, just like we've been doing, right? So let's say we have a number x equals -6 because it's less than -4. When we test that out, we end up getting -162 is greater than or equal to 0, which is false. We can test at 0 because that's in between -4 and 3. We end up getting 36 is greater than 0, which is true. And then we can test at a number that's greater than 3, let's say when x is equal to 5. Well, that simplifies to 36 is greater than, or sorry, these should all be greater than or equal to, right, 0, which 36 greater than or equal to 0, that's true, right? So we care about these two intervals. But they're connected, right? So all we have to say is that it's going from -4, and again, we have brackets here, because it's greater than or equal to, and it's going to go all the way to infinity, right? Because this is going to keep going. We always put parentheses around infinity. All right, cool. If you guys have any questions on this, feel free to reach out. Great job today.